Hello friends, I'm Saket Bansal. I run a company named iZenBridge's Consultancy Private Limited, and we help people in learning or enhancing their skill in project management. We run programs for Agile as well as for PMP certification. And in this video, I'm talking about economic model. This video is part of our PMP math series where we are trying to help the test taker by demystifying various mathematicals or numerical related questions which are frequently seen in PMP exam. In this video, we will talk about present value, net present value, internal rate of return, benefit cost ratio, and payback periods. These are the terms which are used while we are selecting project on the basis of its economical reasons. Let's look at the concept of the time value of money. Money you get in 5 years is not worth as the money you get it today. If you have an option where you can get $5,000 today and the another option is giving the same amount of money after 2 years, you will definitely go for the option number 1, because you need to discount that next 2 years the money which you are getting after 2 years by some discount rate. You may deposit the $5,000 which you get today, and in 2 years time you can earn some interest out of it. So that is what is represented in the concept called the time value of money. When we are making the financial decision, we should also give a proper attention to the period at what particular point of time the cash is coming in or going out from your cash flow. Let us look at the first concept or term, the present value. Now the present value can be looked as the value of money in present time or a value of a future cash inflow in a present time. The formula looks simple, where we divide the future cash flow with a period with an interest rate raised to the power the period, as many period away that particular cash inflow and outflow is. If you look at the element value, we have a future value, and I is a discount rate, and N represents the period. Let us look at an example. Now, if we want to calculate a present value of a $4,000 which we are expected to get after 2 years, we need to divide it with a discount rate. So in this particular calculation, I am assuming a discount rate of 10%. So we divide 4,000 divided by 1 plus R, which is 10 divided by 100 raised to the power 2, because this period is 2 years. So it comes to a 4,000 divided by 1.21, which becomes 3,305 approx. So now this calculation tells us a 4,000 rupee dollar which we are getting after 2 years is equal to $3,305 which we earn today. Let's take an example. For example, you have two investment options. Investment option A gives you $4,000 after 2 years, and investment option B gives you $3,500 after 1 year. Since both the investments are giving return at a different time period, you cannot just compare the absolute value, like you cannot compare 4,000 with 3,500. Now you need to calculate both of these term in a present value. In order to calculate the present value, you need to know what is the discount rate. What should you rate or value you should give to the time period. So for example, the given discount rate is 10%, and with 10%, if you calculate the present value of $4,000, it comes to 3,305. And if you calculate the present value of 3,500 by discounting it once, you get 3,181. Do remember, the change in discount rate may change your investment decision. If discount rate is 20%, maybe option B is highly likely to become a preferred option because it is giving you the returns sooner. Now, how do we use this present value? A present value can be looked as an elementary term in order to calculate the net present value, which is more frequently used in while making an investment decision. But in case you have a very simple decisions where only one cash inflow or outflow is happening in a given situation, you can use present value for making investment decision as well. How do you make it? The higher the present value, the better it is, because it means that given investment option is giving you higher amount of money in today's term. Now the second concept is net present value. A net present value is frequently used in making project decisions, and it helps us in telling that this project is expected to make this much money. So it considers multiple cash inflows and outflow. In the previous term, we were only using a one value and calculating that particular future value into a present term. But in net present value, we may have various future cash inflows and outflows. For example, after 1 year you will get $5,000, after 2 years you will get $8,000, and similarly the two projects which are in discussion are having different outflows also, which are happening at a different point of time. So while we calculate a net present value, it's a simple calculation where we calculate the present value of all cash inflows and outflows of a given project, and we sum it up. By summing it up, we calculate the net present value of a given investment decision. So the formula looks simple. It's a sum of a present value or a sum of a future value divided by 1 plus I, which is a discount rate power to the n, because future value divided by 1 plus I power to the n is a formula of a present value. So I represents the discount rate, n represents the period, and FV represents the future cash inflow or an outflow. Now when we are calculating the net present value, we use a positive sign for the money which we are getting, and we use the negative sign for the money which is going out of the project, like you are spending the money. Let's take an example. So here you have a situation, a given project where you need to invest $1,000 now. You can expect a further investment. You need to invest $1,000 again after 1 year, and you can expect $4,000 at the end of 2 years. So we have 3 cash. Now we need to calculate the net present value. So first we need to calculate the present value of all these 3 options. Since $1,000 is happening now, so the present value of $1,000 remains $1,000. The $1,000 which we are spending after 1 year need to be discounted by 10% with raised to the power 1, because it is happening after 1 year. And the money which I am getting after 2 years need to be discounted twice, because it is coming after 2 years. So the final terms comes to figures comes like minus 1,000 because of now, minus 909, it is coming 1,000 divided by 1.1 discounted once, plus 3,306, 4,000 divided by 1.1 twice, so like divided by 1.21, which gives me 3,306. Now what I need to do it, I just need to sum it up. When I sum it up, I get a net present value of a given project is 1,397. So 1,397 US dollar is a net present value of a given project or an investment option. Now in an exam, you may get a questions where there are multiple projects which a management can decide on, and since this topic forms under economic decision making or economic model of selecting projects, you need to select the project where NPV is the highest. So if you have a project like project A is giving 40,000 after in 4 years, project B is giving 45,000 in 3 years, and project C is giving 62,000 in 6 years. Now a lot of time people think that since I am getting returns sooner, why don't I select option B where I am getting 45,000 in 3 years. Now do remember, when the term net present value is suggested or used, you should always keep in mind that time value of money is already taken care. So if the amount of cash inflow and outflow is already discounted by the discount rate, so you can fairly make a decision just by looking at net present value. So in this particular case, option C is the right option. Net present value is very frequently used term or technique for selecting projects when we are making selection on the basis of economic value of a project, because in net present value we consider cash inflow and outflow, and that is also happening at a distributed point of time. It's relatively easy to calculate, and the negative value of NPV represents that we are losing money in this particular project. So from exam point of view, you should remember the higher the net present value, the better the investment decision is, the project is. Internal rate of return, a term which is a percentile term. Now internal rate of return is a measurement of how quickly, at what rate our money invested is giving us a return. So it can be looked at as a rate of return which is calculated on the basis of inflow and outflow of the project. While calculating net present value, we were assuming a 1 discount rate, and on that basis we were calculating the end value of the project. While we calculate the internal rate of return, we just consider cash inflows and outflows, and we calculate that rate, the discount rate or a rate of return which we can get from this particular investment decision. Now the formula is at what particular rate the net present value becomes 0. So it's like if I discount the cash inflow and outflow and both of them becomes equalized, so net present value becomes 0 when the inflow and outflow of the money is equal. So at what rate this inflow and outflow equalizes each other, and that is the rate of return I am getting from this investment. So for example, if you are investing X amount in a bank, and bank is giving you a return of Y amount after 1 year, if you discount the Y amount with the rate of return which the bank is providing you, it would be equal to the X amount which you are investing today. So the rate of return, the bank interest rate, is the one which equalizes the present value and the future value, and that is how we calculate internal rate of return. So we sum all the cash inflows and outflows, and we calculate at what particular rate they becomes equal or net present value becomes 0. It takes a bit time or some specialized tool to calculate internal rate of return. It's not that easy to calculate internal rate of return as we did it in net present value or a present value. So let's take an example. So we have 3 cash flows. We are spending $1,000 today. After 1 year we need to spend $1,000, and after 2 years we need to spend $4,000. So the same NPV formula, same example. If I put minus 1,000 divided by 1.1, which not 1.1, minus 1,000 divided by 1 plus I divided by 100 raised to the 1, plus 4,000 1 plus I divided by 100 raised to the power 2,000. Now what I have to do, I need to identify the value of I which can make this whole equation 0. So I can try various numbers, and whenever I put 56, so if I put a 56 at the place of I get an approximate 0 value. So it represents that 56 is a rate of return which equalizes the inflows and outflow, and I can say that 56% is the internal rate of return of this project decision. So it is telling me that this project is returning money at the rate of 56%, and that is called internal rate of return. We can use internal rate of return for selecting projects on the basis of higher IRR, internal rate of return. So in this example, a first project is returning higher internal rate of return. Now you may look at the second column and may think that yes, the gold project is returning the highest, but it also needs the higher the investment. It needs $4.5 million, and then only it can return 6% of internal rate of return. When you are handling exam, you need to know various details about the organization before in reality you can make this decision. But for an exam, since those details are not shared in the question, you can fairly make your decision on the basis of internal rate of return if that is the one asked in the exam. Now, how do we use it? It is frequently used in project selection because it's a percentile term. Rather than giving you an absolute number, it tells at what rate a given project is returning. Now, the present value and net present value expect us to assume a discount rate. Now, assuming a discount rate itself is a big exercise, and the discount rate may vary from time to time. It's not necessary the same discount rate can remain for 5 years. Usually the discount rates are taken on the basis of interest rate in that particular country, or some factor, if we apply some factor on top of the interest rate. So good amount of analysis and assumption goes while we calculate that the discount rate for our calculations. In internal rate of return, you don't have to do that. The calculation itself is giving you a rate of return. So that is one of the advantage of internal uses of internal rate of return. So for an exam point of view, higher the internal rate of return, the better the project is, because you are getting better return in that particular investment decision. Now if we compare net present value and internal rate of return, net present value gives you an absolute term benefit that this project will return 100,000, 200,000 US dollar, and the internal rate of return gives you a percentiles output that it will give a 10% return or a 56% return, because 10% return may become a less value compared to, or 56% return may become a less value than a 10% return in some cases, because the total size of project is small. So internal rate of return gives you helps us in comparing various investment decision where we want to avoid the absolute value. Now in reality, when you are comparing various projects, you may get a contradictory recommendation from net present value and internal rate of return calculations. The way I was telling that there is a possibility of having 56% internal rate of return, but the project is very small, so net present value of that particular project investment is small also. But the other one, which is giving 10%, is showing higher net present value. But from exam point of view, you don't get those confusing questions in your final exam, because in order to make decision in the real environment, you need to know various background information. So you can fairly take that whenever you get an NPV related question, you need to pick the one where NPV is the highest. When you get internal rate of return, you need to pick the one where internal rate of return is higher. And in case you get where these two are giving contradicting information, then you need to look other clues. The detail or a background information of that question, which will help you to eliminate one of the option. The next term is a benefit cost ratio. A benefit cost ratio is a ratio of benefit divided by cost, benefit and cost. So it can be looked as a ratio of revenue divided by the cost. We should remember that revenue is not equals to profit. Revenue is like what we get, what we sell out of this particular project or out of this project investment decision, and what cash or a cost it occurs. It can also be looked as a ratio of cash inflow and outflow, because revenue is something which you are getting in and cost is which you are paying out. Now, how do we look at this benefit cost ratio? The greater the benefit, the greater the ratio. So if the benefits are more than cost, we will get the higher ratio. Now let's take an example, kind of a PMP questions, where you have various projects and their benefit cost ratio is given. You may find a cost benefit ratio as a term which is just like a reverse of a benefit cost ratio, because it's a ratio of cost divided by benefit. So for on option B, you need to calculate the benefit cost ratio, which would be a 1.11 if you do 1 divided by 0.9. In option C, talking about cost of 100,000 and benefit of 110. So you need to calculate 110 divided by 100,000. And in project D, we directly have the value which is 1.2. So out of these projects, these 4 projects, we can see that benefit cost ratio of project D is the highest. And if you have to make a decision on the basis of BCR or benefit cost ratio, you will pick the project D. Now, how do we use it? It helps us to visualize the relative value, because if you have various investment where the absolute value may be different, benefit cost ratio talks about that what I get after this much investment. So it's a ratio term which can help us in comparing various projects where we keep their absolute value or an investment value separate. It is easy to calculate. Now, usually when we calculate a benefit cost ratio, we do not include a time value of money. We just use that the cash inflow or a revenue and divided by the expense or an outflow which we make during the project. But if needed, you can also calculate a discounted benefit cost ratio where you also factor in the time value of money. What does it mean? Means you also factor in when this particular income or this particular expense is getting executed in your project decision. So you can discount it by the time value. It's easy to calculate and easy to explain. So if you use the simple benefit cost ratio for stakeholder communication, it's easy to understand. A ratio which is less than 1 indicates that we are losing money. Same like a negative NPV. So it's the higher the value, the better it is. Payback period. Now till now all the terms were dealing with cash inflow and outflow and ranking the project on the basis of how much money the given project is making, or at what percentage in case of internal rate of return the money the investment is returning. But in a payback period, the calculation is happening in terms of time. Now when I say time, the payback period represents that how soon or in how much duration you get your investment back. So if you get your investment back in less than 1 year against another project where it takes 10 years to get the investment back, you will definitely prefer the one which you can get faster. So when you are making a decision on the basis of payback period, you will pick the project where the time difference, the time period is shorter. Now let's take an example. If there is a project, so now a lot of time what happens is that you may need to calculate the cash inflow before you can calculate the payback period. Now you can visualize it. It is as a place, as a point where cost and benefit becomes equal, where cost benefit ratio or a benefit cost ratio becomes 1, or where the investment becomes equals to the amount of money return we get in a given period. So you, in order to calculate a payback period, you may also need to calculate how the money is flowing back. So you may find a question where it talks about that project A requires investment of 500,000 and it is expected to generate 25,000 per quarter for the first year and 100,000 per quarter after that. So we need to calculate that how many quarters it will take before I get 500,000 back. Now how do we do it? So we can think of a first year 25, 25, 25, 25. So at the end of a year we will get 100,000. Second year, since quarter means 3 months and 1 year has 4 quarters, in second year I will get 400,000. So in 2 years time I will get my 500,000 back. So for a given project, the payback period is 2 years. So it be possible that you have a direct calculated value given for the payback period, or you may need to calculate the payback period and then compare the project, which one is giving the shorter or a faster return, or a payback period is shorter for which. Now, how do we use it? It helps us in looking at the time dimension of an investment. The sooner we get money, better it is. And usually it is calculated just by taking the direct value. So in the previous example, we have not considered the time value of money. We have not spoken about the discounted value, because if you are getting money after 1.5 years or after 2 years, the 100,000, you should have discounted it because you are paying 500,000 upfront. So the absolute payback period, we usually do not consider the time value of money, but we can also calculate a discounted payback period, where we can also discount the future cash flow, be it inflow and outflow, on the basis of time value of money. But from an exam point of view, you just assume that a pure sense payback period is calculated without considering time value of money. Means you need to just directly sum the cash inflow and outflow without discounting it by any rate. Now this is the summary, and usually this slide should be good enough to answer questions related to project selection. Now the previous slides helps you to make an idea or a background of these various terms, but this gives you a summarized information. So a present value, when you get a question related to a present value where the options are giving various present values, you need to pick the one where you get the most. So higher the value, the better it is. Same goes for net present value. The negative net present value represent loss, that you are losing money in a given project. So you need to look for the higher the value. Internal rate of return, it's a percentile term. Higher the percentage return, the better the investment option is. Benefit cost ratio, since benefit and divided by cost, so higher the benefit means higher the ratio. So ratio more than 1 represents that benefits are more than cost. Ratio less than 1 represents that benefits are less than the investment, means losing money in this particular project. So higher the benefit cost ratio, the better it is. Payback period, it represents how soon you can get your money back. So shorter the payback period is, the better it is. And these are our contact details. You can visit our forum. We have a section, exclusive section for our customers, and we also have open sections where you can raise your various queries related to PMP exam certification. In order to get a regular update about our various hangouts and web sessions, you can follow us at one of the social channel. You may like to follow us on LinkedIn or Facebook or Google Plus or all of these three. It will help us in communicating with you on real time. Feel free to post your queries related to PMP at our social or at our forum communication channel. Thanks for watching this video. I am Saket Bansal from iZenBridge Consultancy Private Limited. Thank you.